Math 3 Lesson Summary Video, Circling Triangles, or Triangulating Circles. This lesson is a develop understanding task, which is meant to introduce you to a concept, but not necessarily finalize rules or strategies. The purpose of this lesson is to derive the equation of a circle on a coordinate plane using your knowledge of right triangles. Using the corner of a piece of colored paper and a ruler, cut a right triangle with a 6-inch hypotenuse like so. Use the triangle as a pattern to cut 3 more just like it, so that you have a total of 4 congruent triangles. So it's important as you're cutting out your piece of paper, you're basically going to cut all 4 corners off, but we want to make sure that we can get 6 inches here. So however you arrange your triangles, you want to try and keep that 90-degree angle. Factory cut paper is probably going to be a little more precise than I do it. So if I can use the factory corner, I'll be better off, and I know I'll have a right triangle. But you want that hypotenuse to be 6 inches. And then you want to make sure that you have 4 congruent triangles. Choose one of the legs of the first triangle and label it X, and label the other leg Y. So we're going to do that for our triangles. I'm going to let my short one be X and my long one be Y. It doesn't matter which one you choose. In fact, in the class, everyone's triangles are going to turn out to be different because how you arranged your 6 inches could have been very different. You could have made your hypotenuse go this way. You could have chosen to make yours go kind of like straight across and be 6 inches. So there's going to be a whole lot of different sizes. You could have made a really skinny one and made your 6 inches go that way. So you're going to have a bunch of different people in your class with a bunch of different size triangles. But once you get all 4 of them, you just want to get them labeled X and Y. When you are told to do so, take your triangles up to the board and place each of them on the coordinate axis like this. Mark the point at the end of each of your hypotenuse with a pin. So notice that you want the hypotenuse to come down and touch the origin, 0, 0. So you're going to have the part that's labeled X and the part that's labeled Y out here. X should be on the x-axis and Y should be going up and down off of the y-axis, but you want to make sure that 0, 0 has one of the parts of the hypotenuse, and then the other end of the hypotenuse is going out here. You're going to then put a dot on all 4 of those corners out on the outside. Now, when you do this with a whole class, it turns out to look something like this. So you have a whole bunch of a different sized triangles kind of on top of each other and a whole bunch of points out here. What shape is formed by the pins after the class has posted all of their triangles? Why would this construction create this shape? So when we looked at the picture, if you noticed, all of these dots out here, you really kind of get this big circular shape. It does in fact create a circle. Now, why would it do that? Well, if we think about it, the part that's going from 0, 0 to the part that's coming out here, we were very purposeful and we made sure that that was the hypotenuse. That was the one thing we all had in common. Remember, all of us had a hypotenuse that was 6 inches. So if everyone's hypotenuse went from 0, 0 and out to where they drew their dot, then this is just a collection of dots that are all 6 inches away from 0, 0. And a collection of points that are all the same distance away from the center is the definition of a circle. So what are the coordinates of the pin that you placed in the first quadrant? So remember, we had named our sides of our triangles. One side was X, and we put it on the x-axis, and then one side was Y, and it kind of is the one that's stuck up. So if we think about coordinates, remember, how much you go to the left and right is your X coordinate, and how much you go up and down is your Y coordinate. And if it's in the first quadrant, This is going to be a positive number and a positive number, so it's just going to be x, y. Over in the second quadrant, because we're going the same distance, x, whatever that x happens to be, it's just going left. That's the negative direction. This is going to be a negative x and a positive y. Down here, we'll get negative x and negative y, and over here, we'll get positive x and negative y. So this is the coordinates for our circle. How could we then possibly write an equation that's going to represent all of these points? What kind of relationship could these x's and these y's possibly have to do with one another? And our big key here is the fact that we used right triangles. We made a very purposeful point of making sure we had our factory edge with its 90-degree angle, because when we deal with triangles, specifically right triangles, we can always use the Pythagorean theorem. Anytime we can use right triangles, we always want to remember the Pythagorean theorem. And so if we think about each of our triangles, one side of the triangle is x amount, one leg of the triangle is y amount, and the hypotenuse of the triangle for us was 6. So now we have x squared plus y squared is equal to 6 squared. And that would represent any of our triangles, because all of us made one side x, one side y, and our hypotenuse was 6. This would represent all of the class's triangles. Without specifically knowing what x and y was, it would still represent all of ours, and all of ours gave us like all of these points all the way around the circle. There's a few we didn't have, but I'm sure we could go and cut some more triangles to kind of fill in those little gaps there in the middle. And then we would have all of the points. Now, is this point 0, 6? Is 0, negative 6? Excuse me. We could test it out. Does 0, negative 6 fall on our circle? Well, if we wanted to know if it was on the circle, remember that's the point of an equation, is that I can test it out. So if one of the sides of my triangle is 0, which we know isn't really a triangle, it's just a line. And if one side is 6, then yes, that's going to work. Those are going to be equal. And so this point would be on our circle. In fact, it's probably that point right there. And so now we have an equation that we can represent our particular circle with. It's a circle with a center at 0, 0 and a radius of 6. Now, if we wanted to take this circle and we wanted to move it, let's say we wanted to move the center, instead of being at 0, 0, we want to move it 3 units to the right, and we want to move it 2 units up. 3 units to the right and 2 units up. This is where remembering our transformations is going to have to be really important. When we're moving things on the graph, if it moves left to right, which variable does it change? Remember, this is the x-axis, so it's always going to change the x. If it's moving up and down, that's on the y-axis, and so that's going to change the y value. Other things we learned about transformations is anytime we change it before we do the function, which in this case it looks like we're going to be squaring, but if we change it before we square it, that means that we always end up doing it backwards. So instead of 3 being positive, it's really going to be negative. Now, usually we're used to y always staying the same, but notice we are moving y before we square it. We're moving the circle before we try to use all the triangles to find the equation. So it's going to be backwards as well. So it's going to be y minus 2 squared. And we didn't change anything about this part because all of our triangles are still this way. Now, if you don't remember your transformations, one thing that we can do is say this equation works if it's 0, 0. We know that this works if it's at 0, 0. So if we move it to the right 3, I just want to subtract 3 to make it still be 0. You know, I still want it this value to be equal to 0 instead of something else. So if now I'm making x equal to 3, I'm going to have to subtract the 3 from both sides to make it equal to 0. And I would still want y to be equal to 0, but it's equal to 2. So I'm going to have to subtract the 2 from both sides. And so that's why we use y minus 2 for that part. But this gives us an equation for our circle. So if we want to think about a generic, always going to work equation for our circle, we generally write it as x minus h squared plus y minus k squared is equal to the radius squared. And just remember that hk, just like when we were doing transformations, hk is always kind of how we represent those transformations. This is always going to be the center of the circle, so we can move that center wherever we want it to be, up, down, left, right. Just remember that when it's inside the parentheses, we always do the opposite of it. So if this is 2, 3, I'm going to do subtract 2, subtract 3. It's always the opposite of the inside. And our radius determines that hypotenuse. And this is always just a squared plus b squared is equal to c squared.